Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, we are going to discuss a very important property for our Kafka topic, especially for production system, and that is log compacted Kafka topic. Okay, what is this particular concept? How to get in-depth intuition on this particular concept using programming? All these concepts today in this particular video we are going to discuss. But before going ahead with further discussion, you should have a clear idea on Kafka logs. Okay, in one way we can say Kafka basically acts like a file system. Within our broker, the topics are nothing but folders. Within folders in different files, we can call that files are nothing but Kafka segments. Within that, the messages are getting stored. So the notion of Kafka as file system, on this you should have a clear idea, which I already covered in my previous video in detail. The prerequisite links I'll be providing in the description box or in the comment section. If you want, you can go through that, because those videos will surely help you to understand today's topic in a much clearer way. So without any further delay, let's start our discussion. So suppose here we are having our Kafka server. Okay, so this is called broker, and within these brokers we are having multiple topics. So suppose here we are having a topic A, and the producer is publishing real-time data in a very high speed in this particular topic. Now Kafka basically acts like a buffer, right? So when suppose you are having a consumer, the consumer is not able to process the data in such speed in what the producer is publishing, then also no problem. In this particular topic, the messages will be queued up, and in first in first out format, the consumer will be keep on processing the messages. So one thing you can understand that within this particular Kafka server, the messages are stored, right? Even suppose one particular consumer has consumed the messages, then the messages will not be deleted automatically. You can maybe consume the same messages using some other consumers belonging from some other consumer group, right? So here in this particular topic, the messages are not getting erased or removed as soon as it is consumed. It stays for a certain amount of time. Ideally, it stays for 7 days. After 7 days, the messages get deleted. Now think about a particular situation where the producers are publishing the messages in a very high speed, and the broker is not having that much high configuration with respect to memory. Okay, so what problem will happen? That producers are continuously publishing the messages in this particular topic within the broker, although the broker don't have that much space remaining. So obviously after a particular amount of time, the system will crash because there will be no space remaining. Whole system will be down. For that, sometimes we reduce the retention period of messages within a particular topic from 7 days to some particular day, maybe 1 day or 2 days we keep that messages. So these things we can configure in topic creation or in server level. Let me show you that how it is configured generally. So here I can go to my folder where Kafka is installed, and I can go inside config folder. Here if you see server, just search with retention, and here you will see log retention policy, right? And if you see, the first property is log retention hours, the minimum age of log file to be eligible for deletion due to age. So whenever the messages are old enough, the Kafka automatically delete those messages, right, or logs. So log retention hours by default is 168 hours. That is, after 7 days, the messages get deleted from our Kafka system. Or this particular configuration also you can do, which is indicating log retention bytes. That is, if this much bytes of data is accumulated, after that, if further messages are coming, then the old messages, the Kafka will start removing, or it will try to delete from the system. Then here log segment bytes. Log segment bytes is anyway a separate topic which I covered. That is, within topic, we are having partition. Within partition, the data is divided into multiple segments so that in one single file, huge amount of messages will not be stored. Okay, right? This is not having so much importance with respect to retention. But yeah, this also plays a very vital role in dividing the messages into different files, right? And here, if you see another property is log retention check interval MS. That is basically indicating the interval at which the log segments are checked to see if they can be deleted according to the retention policies. That is, here we have configured after this much hours the old files can be deleted, or after this much bytes of accumulation of data the older files can be deleted. But when we will do that check, that we will check only after this much interval. Okay, so these are few properties based on which from Kafka the old messages are getting deleted. Okay, right? So that is one way that we can delete the message which are older than a certain time, right? Apart from that, there is another option, and that is coming under this topic, that is log compacted theory. What is that? Let us try to understand. So to understand the log compacted topic, let us try to consider a real-time scenario. Okay. So here we are having Kafka offset. Here we are having key, and here we are having value. Suppose initially it will start from offset 0, obviously. And suppose the key is employee ID, the value part is storing employee salary. Suppose for employee ID 1, the value is 100, the salary is 100. Then for offset 1, suppose for employee 2, the value is 200. So these data are continuously coming from source system in real time. The producer is publishing, and the offsets are gradually increasing as and when the producer is publishing the messages in Kafka topic, right? So suppose for offset 2, for employee ID 3, the information came, and suppose his or her salary is 300. For offset 3, employee ID 4 came, and the salary is 400. Like that it is coming. Okay. Now, obviously in the backend, after a certain number of accumulation of messages, segments will be created, right? So here maybe let's consider this is segment 0. Like that the messages are continuously coming. Suppose currently the offset is running at offset 45, and here suppose for employee ID 5 the salary came, that is 500, and then offset 46 the employee ID with 1, that employee salary suppose got revisited, and that salary got increased to 400. Okay, and suppose these informations are available in segment 1. So in this case, you can understand that employee with ID 1, that employee's initial salary was 100 and the current salary is 400. Okay. So this is basically the latest information. Now suppose your system is built such way that your system don't bother about employee's past salary. Okay. That is this particular value for employee ID 1, the initial salary was 100. That is no longer important. In our case, the important is current salary for employee 1 is 400. Okay, right? So what in log compacted topic it does, it basically maintain the most recent entry for a unique key. So what will happen in the backend, one particular program will run, and that will compact these particular segments and will create a new segment where the offset will be like this. Offset and then key and then value. And then here, see, for 2, 3, 4, it is not repetitive. So offset will be 1, 2, 3. For employee ID 2, 3, 4, whatever was there, that will be coming. That is 200, 300 and 400. Okay. Now here, for this particular employee 5, suppose this first time this record arrived. So that will be also remaining. So offset is 45. The key is 5 and the value is 500. Okay. Now offset 46. The employee ID 1's data will be coming with the updated salary, that is 400. So in this particular new segment, what you are getting, that the employee's older salary, that is this particular row, is no longer available. Okay, because this is not required in our system. That's why after performing log compaction, the particular entry got deleted. So in simple words, here in this particular case, the messages are not getting deleted based on time. That is, older messages beyond a particular time, just delete those what we observed in the server properties. Based on that, the messages are not getting deleted. In this case, Kafka basically maintain the most recent entry point for every unique key. Deletion are not based on time. Only when the unique key gets overwritten, like for example, the key is 1 got overwritten this case. That means for that employee ID 1, the salary got increased to 400 or decreased, whatever activity happening. If you are bothered about that, then no need to store that older record, right? So that's why we are deleting that from the system. So that's what the log compacted topic does. And another very important point to note, in this particular case, log compaction only removes the messages but does not reorder the messages. Like if you see here, for the offset 0, for the employee ID 1, the value is 100, that got removed because here we are having at offset 46 the updated value, right? But rest entity you see offset 1, offset 2, offset 3, that is having same information. Then here offset 45, that is also same. for employee ID 1 in offset 46, it got revisited. So here it came. So actually it is not reordering the messages. It is just keeping the latest unique key related entity. That's all, right? So I hope you understood the fundamental concept of log compaction. Even for example, in change data capture, you can implement this kind of log compaction based deletion in case of your Kafka topic, so that your whole system will not be overburdened. Like for example, suppose for one particular primary key 1, the current name is A. Okay. Then after some time, for that same primary key 1, the name changed to B. So in case of change data capture, what will happen? This message will come to Kafka topic. Again, this message will come to Kafka topic. Now suppose you are creating a destination system where in the source system whatever changes happens, that same thing has to be replicated. In that case, in the target system for the primary key 1, the latest information should be present. That is here 1, B should be available in the target system. So here in this particular CDC case also, we can implement log compaction based topic. That is 1A, it will be deleting if for the same unique key or primary key 1, if it is getting one more record, right? So this log compaction based deletion or cleanup you can implement in various places. Whenever the complete tracking or complete history no need to maintain, just the latest information that much only required, then in that case you can follow this particular technique instead of time based deletion. Okay, and the same concept is shown in this particular diagram. Suppose this is within a particular topic, within a particular partition, the offsets are continuously increasing 0, 1, 2 and so on. Now here we are having key and here we are having value. First the key K1 came with the value V1, then the key K2 came with value V2, then the key again K1 came with value V3 and so on. Now see, after log compaction we are getting this particular output. How it is coming? Observe carefully. Here key K1 value V1 is available, right? But it is not coming in the output. Why? Because here again for the same key K1 another value came. So this is basically the latest one, right? So that one is coming here. For the key K1 value is V3 and the offset is 2, that is coming. Now you might ask why this particular record is not coming before. The reason is this particular K2 also got revisited at offset 4. Okay. So for K2 after log compaction only this particular entity is there, right? So that's why this particular record has not came. Now see here K3, for that key there is no new unique value came. So here K3 is coming in the output. Okay. Then here K2. For K2 this is the latest record. So that K2 is coming here. Right. And then for K4. See K4 is not repeated. So for K4 this is the latest state. That only came. For K5. See offset 6 is not the latest state. Okay. Because at offset 7 also K5 came. That's why it is coming in the output after log compaction. And for K6 it is the latest state. So that's why after log compaction it is coming. So in simple words, you can think that if the unique key is again getting repeated, then the older one's log compacted topic will be deleting and it will be keeping only the latest state. But while doing this deletion, it will not reorder our messages. Ordering of the messages are kept as it is. Like here you can see that here K1 is there, after that K3 came, after that K2 came. So that same thing is maintained here. Okay. The offset 2, 3, 4, 5, 7, 8 like that it is maintained. In between offset, after compaction there can be discontinuity, but the offsets are continuously gradually increasing. That's the point. Okay, right? So now let's fill this particular concept with practical, and we are going to implement this particular practical by launching a Kafka cluster in an EC2 instance. All the codes I'll be providing in the description box or in the comment section. Please try to parallelly practice and get the idea out of it. When you will do the lab experiment simultaneously, the concept will be much more clear. Okay. So here I will go to my AWS management console in the EC2, and here I will launch one EC2 instance for this demo. Okay. So here I'll go to instance, launch instance, log compaction demo. That is done. And then here key, I'll be selecting one existing key. Networking setting I can keep as it is. Maybe I will check this HTTP traffic, and then here I will launch the instance. So here our instance is launched. Let us go to that. And here it is in pending state. Let's wait for a few seconds to spin up. So here see the instance is running. I will take the public IP and I will make sure that all IPv4 traffic it is allowing. So I'll edit the inbound rule from security group. All traffic from anywhere IPv4 I want to allow for this particular EC2 because just we are doing for demo purpose. And then here I can open putty. I will take the key file what we already having, and then here I will do login as EC2 user. Okay, to make sure it is not having timeout issue, I will change the setting to 10 seconds and apply it. Okay, I will just also increase the font size little bit. I'll go to appearance and then maybe change, and then I will keep this 20, apply. Yeah, now it is looking better. Now what I will do, I will first download Kafka and unzip it. So using tar command we are unzipping, that is done. Now let's check whether Java is there or not. With Java -version, see Java command not found. So we will install Java and then again execute Java version. Okay. Yes, let's continue. And then we will check Java version. So now when we are doing, we are able to see the Java version. Now I will go to that particular directory where Kafka unzip happened, and then here I will start the zookeeper first. Okay. So here our zookeeper is started. Now in a new terminal, I will start my Kafka brokers. So I will duplicate this session and log in as EC2 user only. And then before starting the broker, obviously I need to make sure that in server properties in listener we are configuring the EC2 public IP. Already we discussed several times on this particular topic. In advertise listener we need to configure that. So here I will copy the public IP and I will use WinSCP to go inside that EC2. The username is EC2 user, and then here I will open the ppk file. Using that we will enter in this, and then here we will go to this directory, and then here we will go to config, and then here server.properties. In that we need to do a change, and that is basically the public IP we need to put in advertise listener. Here in your host name I need to paste that. I will save this one. Okay, and I will keep this somewhere saved in my notepad file also. Okay, maybe here, right? So this is our EC2 public IP. Now here to run the broker we need to execute these three pieces of code. First we need to set up the environmental variable, then we need to go to this directory, and then we can run server.start.sh file. So here let us hit enter. So here our Kafka server is also started. I will duplicate this session and I will enter in that terminal using EC2 user. Okay, now what we need to do, we need to create the topic. To create the topic I need that bootstrap server or broker URL. So I will use that particular command. Okay, first I need to go to this particular directory. I will go there, right? And then I need to execute this particular command, kafka topics.sh. Now to create a log compacted Kafka topic, we need to do little configuration while creating the topic. See here kafka topic.sh, and then here topic name we are configuring. The bootstrap server we have configured whatever we are having. Replication factor only one keeping, partition also one keeping just for demo. Now cleanup policy is generally delete type. That is older messages get deleted based on time. But in this case we want to create a log compacted Kafka topic. So here we need to write cleanup policy equal to compact. Okay. Then here this is very important. Mean cleanable dirty ratio, that is 0.001. This value we have configured. So this basically controls the threshold. So suppose mean cleanable ratio is 0.5, then it is indicating that at least 50% of your topic or partition data should contain dirty entry for compaction to run. When I say dirty entry, that is basically meaning that for one particular key, multiple entries are there. So in that case, we are having a scope to compact that particular topic and keep only the latest messages for the unique keys and delete the older ones, right? So to do that, how much dirtiness in your data you should be having, that you can configure using this particular threshold. Okay, dirtiness of 0.5 means at least 50% dirty data you should be having in your topic or partition. Suppose I am configuring 0.001. Why I am keeping this small value? Just to show you that the log compact is happening. If we are keeping 0.5, then we need to wait little bit more time, right? That is, our data need to be 50% dirty. But because I am keeping here very less value, so we can visualize log compaction very quickly. And then here segment.ms we are keeping 5000. So anyway, this already we discussed in our previous video. That is, with each 5000 millisecond interval, a new segment will be created within a particular partition within a topic in our Kafka. So here, most important property related to log compact Kafka topic is cleanup policy should be compact and mean cleanable dirty ratio should be based on what percentage you want to compact. Okay, right? So here I will create this particular topic. And here see, the topic got created successfully. Okay, cool. Now here we will start producer and we will start consumer. Some keys we will be repeating and we will see for that same key older values get deleted from this topic or not automatically, right? So for this particular demo, what I will do, I will just make this particular screen little bit smaller. So now these values are looking bit bigger. So I will just change the setting. Maybe I will reduce this value to 12. Okay, and apply it. So this is our producer side. And then I will duplicate this session for consumer. Okay, I will start Kafka console producer and Kafka console consumer here, right? So here I will go to this particular directory and then here I will start the console consumer with the proper broker configuration. So our broker URL is this one. So that I will update in the producer as well as in the consumer side. Okay, so here these two codes will be executing for our consumer console. So what is this? This is nothing but our normal Kafka console consumer.sh file. From this particular topic, we want to consume the data from beginning. Bootstrap server we are mentioning, and we are saying that print the key part also, and the key should be separated by comma. Okay. Generally, the consumer only print the value part, but I want to print the key part also with comma separated part. Okay. And now I will start the producer following the same way. So here our console producer started and here our console consumer running. Okay. In the backend, our broker is running here. So here what I will do, first suppose for employee ID 1, the message got published with the salary 100. Then employee ID 2 is having salary 200. Okay. When we are publishing messages, here see in the consumer side, the messages are coming. Okay. Suppose for employee ID 3, the message is 300. Okay. And suppose for employee ID 4, the message is 400. Right. And then for suppose employee ID 1, the salary got revisited and one salary is now 200. Okay. So because our consumer is running from beginning, so here all the messages are getting consumed. But we will see if we start this particular console consumer again from beginning, we will see that older employee information for employee ID 1, that is employee ID 1 was having salary 100 rupees, right? Based on our production of data, that should be deleted due to log compaction. We will see that. Suppose for example, another salary got published. Suppose for employee 5, the salary is 500. Okay, right? Now let's see whether log compaction happen or not. And what I will do to see that, I will just stop the console consumer and then I will start it again from beginning. Okay. And now from beginning, when I will try to consume the data, if log compaction happens, then we should not see for the employee ID 1, the salary 100, because it should be deleted, because already for the employee ID 1, the new salary came and that is 200, right? So let's run it. Here you see that employee ID 2 salary 200, 3 salary 300, 4 salary 400 came, employee ID 1 salary which was 100 in the beginning, that got deleted automatically. That's the beauty of Kafka log compaction. For the same unique key, if multiple records are there, then the older one will be deleted. Okay, right? But see, order is not changed, right? Rest order is completely maintained. Suppose now 3 salary also got revisited and 3 salary became 600. Okay, right? Then employee ID 6 is having salary 600, employee ID 7 is having salary 700. Suppose like that, the messages are getting published. In the back end, here basically our Kafka broker is running. If you observe the logs, there also you will get some idea what is happening. Like I told you, right, while discussing the theory part, that is here, suppose segment 0, segment 1 we are having. After log compaction, a new segment will be created. So here if you observe the logs, that some particular snapshots are getting deleted or some particular segments are getting deleted, a new segment got generated, a new snapshot get generated, all these things are getting printed. But anyway, we can check simply from this console producer, console consumer only. So what we did, we basically got revisited salary for the employee with employee ID 3. Earlier the salary was 300, but now for the same employee ID 3, the salary got increased to 600. But because we are continuously running our consumer, so in this particular consumer here, if you see, the employee ID 3 is having 300 as well as the updated salary, both are present. But due to log compaction, the older one should be deleted automatically and only the new value should be present. So let's run this particular consumer again from beginning and see here the employee ID 3 earlier was having salary 300, that got deleted. 2415367, and for the employee ID 3, whatever latest salary we are having, that only it is showing. Why? Because here we have configured such a way that key value both we are passing from console producer, that is key separator in console producer is comma. So Kafka is understanding, okay, the first part is key, the second part is value, whatever we are passing, right? Now here for this particular key, it is repeated. So the latest information related to a repeated unique key, it will be keeping, older one it will be deleting. That way, instead of time-based deletion, it is deleting based on repetition of unique key. And that's the central concept of log compacted topics. And I hope what is the use case of this, that also you understood. That is, in whatever situation, we no need to keep the complete history or all the changes, just we are bothered about the latest changes, like for example CDC or these kind of scenarios, then you can go with this particular technique, right? I'll be providing the course in the description box or in the comment section. Please try to implement that. You will be getting much more feeling out of it. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.